Welcome to my channel. I'm Zhang Xu. Let's look at the problem 57 in chapter 7. In this chapter, we talk about work and energy. As you can see, we have the spring connected with the object, and then the initial state is stationary, and then this spring compressed and pulling the mass, and there is no friction, and then we need to determine the velocity when the spring returns to this location, right? So this one we need to consider this problem. This is just the spring and the object. So the kinetic energy change must be equal to the work done on this object. So what work done on this object? The spring's force. Do you agree? Yes, and the spring's force is kx. It changes with the x, this distance it moves. So there, when we want to find this work, we need to consider integral, because the force is changed with x. And then this spring's constant can be get at there, k equal to F divided by S. No problem, right? Because it tells us the spring which is had sketched a distance x by a force h, by a force F. So this sentence tells you the constant of the spring. The first one we consider the work energy principle. The change of the kinetic energy, you can see this is the final kinetic energy minus initial kinetic energy, must equal to the work. So this work is done by the spring. So this is the force kx, and do the integral with s. So when we do this integral from 0 to x, because it says it returns to its normal length, so this x changes from 0 to x. Agree? And in this one, we find it. We do the integral is 1/2 kx squared, and then we input the k inside, it becomes 1/2 fx. There we can say v1 is 0, so this term becomes 0. Then we can solve this equation, find the v2. This one. The next one, this spring returns to half of its origin extension. So this becomes x divided by 2, right? Half of the extension, origin extension. So initial is x. The second one is x divided by 2. Still the work energy principle. The final kinetic energy minus initial kinetic energy equals the work done by the spring. And this one is there. And then we can find it. Do the integral, find it 3 divided by 8 kx squared, input this term to replace the k, and then we get the final answer look like this one. And thank you.